I'm Brian Winnikins, and we are at the Irrigation Association and National Groundwater Association's annual convention in Las Vegas. And thank you to the Irrigation Association, along with the National Groundwater Association, Annabis Silo of Durant, the Animal Wellness Center of Buffalo Valley, and also BASF Ashley Gaussman, your representative serving Northwest Wisconsin. We're going to talk about some groundwater research with Dr. Richard Layton. He is with California State University at Fullerton, also part of the Earth Forensics project as well. And we're going to talk a little bit about some of the research going on with groundwater. And Dr. Fullerton, or Dr. Layton, rather, thank you for joining us. I just named you a whole city. Thank you for joining us today. Obviously, out in California, groundwater research is probably an important topic.
Very important, and there's lots of it going on. Obviously, with the drought and the need for water resources with such a populous state, there's a tremendous amount of research going on. And clean water side of it, the water supply side of it, and also trying to look at innovative ways to reuse the water over and over again.
And for agriculture, this could be some opportunities here to be able to try to reuse some of the water that's used in their operations, and even maybe to help with some filtration of nitrates and things like that. Absolutely.
With the agricultural side of things, there's a big opportunity for some of the water that runs off the fields to capture it, retreat it, and actually put it back in either the ground or put it back in the fields, as well as the nitrates research. Certainly we're having a lot of issues with trying to figure out where it's coming from, the sources. But beyond that, it's how can we use either nature to try to remediate or clean up that contaminated water, or is it a way to try to figure out how we can control nature in a way that we don't have as much of it going on as maybe we do right now?
You mentioned the storm runoff. Wasn't there a project in California a while back where they were using, I think it was storm runoff coming from a city, and they were bringing it out to the farm to put it out in the field to see what would happen?
Yes, we've done some of this work in the Mojave Desert area as well as in the Central Valley. And they're, again, taking water that isn't drinkable, but is perfectly good and valid for utilizing on agricultural systems. And what I mean by that, it may not be pristine as far as the EPA or the government's concerned, but it's perfectly fine for growing crops. So why not use that water for growing crops and save our money and our energy to try to clean up water that we use for drinking in a different way?
Would this, in some respects, be a, quote, new form of irrigation?
Yeah, I mean, I guess it is in a way, because it's a way to, like we rotate crops, basically keeping that water moving all the time. And by doing so, if we can lower our cost of irrigation and maybe even irrigate the crops in a better way, very similar to what the golf course groups have done. There, they've used fertilizers and everything on the greens and on the fairways, but they utilize man-made ponds and wetlands next to these fairways to capture and treat the excess irrigation, then reutilize that water back, keeping their cost for fertilizers down, which in this case, with the fair agricultural system, could very well be the same thing.
Talking with Dr. Richard Layton with the Cal-State Fullerton and talking about some groundwater research. Obviously, Dr. Layton, is there research going on with trying to replenish aquifers and groundwater? Because I know, like, there's, in California, we've had the land sinking, and there's other issues of that happening in other parts of the U.S. because of the aquifers drying up.
Yeah, one of the things that's happened over the last 10 to 15 years is the ability for us to manage our aquifers by artificially recharging them during times of wet, and then pulling that water out when we need it during the dry periods. And this is something that's being done in Wisconsin, Minnesota. It's not just unique to California or the Southwest. However, the Southwest, because of the drought and the conditions, they've certainly taken a full advantage of it. And in most of the cities, they try to capture the runoff, put it into ponds, let the geology beneath the ground, filter that water, and allow that water to go to their well fields, for example. The subsidence issues is a different one, and that is where we're actually taking out water, not really replenishing it. And in doing so, the hydroconsolidation of the materials are allowing the land surface to sink. And you cannot get back that land surface, or it's not like a balloon where you can deflate it and reinflate it. Once you've lost that, you've lost both the water's come out, you've lost the compaction, and you've also lost your ability to actually put water back in those areas. So it's going to be something we're going to have to address as we move forward in the future.
You mentioned the storage of ponds. I know that in California there's been a lot of talk of that, but I would think this is an issue nationwide. We don't seem to have much use or much expansion of water storage facilities, so to speak.
We don't, and certainly when we think about that, we always think of surface water. From a groundwater standpoint, there's actually almost 10 or 40 times more groundwater available to us to drink or to utilize than there is surface water on Earth that's not salt water. And so it by itself is our largest storage reservoir. But there again, if we don't manage that reservoir and we contaminate it or don't replenish it when we need to, then that reservoir will go away. As far as the surface reservoirs go, we try to, basically flood control kind of came along and helped us with that by allowing us to dam up rivers, in some cases create artificial lakes that we can store water in until we need it. But there again, the problem with surface water is it's exposed. So animals, birds, dust, air pollution, all of that interacts with surface water, where when it's in the ground, the water is protected from all those, and so it ends up becoming a more an easier source and a cleaner source of water for drinking, particularly.
As we move forward, what other are some of the other research projects that the agriculture might be interested in maybe being a part of?
Well, certainly the irrigation side of it's going to be important, partly because can we take that same volume of water we're using and use it on a bigger area? Can we change our sprinkler patterns and do drip irrigation? Those things are all going to be valuable to us in the end because there's costs associated with getting that water to that area. And if you can lower that cost, it certainly makes it more productive. Also, we're finding that before the research I was working on, prior to maybe 2005, we were looking at people just irrigating their homes. And the normal person irrigated their home 350% more than was needed for those same plants. Basically, they're wasting water. And there's probably a significant amount of this being done in the agricultural side of things. But with that said, is with management, we can, when do you need water plants? That's where your agricultural people come in, your soil scientists come in to tell them, okay, it's getting dry, now it's time to water, rather than just watering blindly every day. And this is something that's going to be done upper Midwest, the Central Valley. I mean, it's pretty much nationwide.
We all need water, that's for sure. So technology is going to play a big role in this.
Yes. Technology is not only playing a big role now, but will play even a bigger role in the future because it's allowing us to become more efficient. We didn't know how much electricity we were actually really charging, or were we wasting it because we didn't put the wrong size pumps in the ground, or the surface water had to be cleaned up, where if we had taken the water out a little bit sooner, maybe we didn't have to treat it, and therefore energy costs and stuff. And technology has really come so far to the point where now we can sample it in the field. We don't have to send it off to a lab to tell us how much nitrates are in it. We can get other readings and numbers right in the field to give us better tools to immediately make decisions that can impact the businesses we're dealing with.
Dr. Layton, again, thank you for joining us.
Thank you.
Dr. Richard Layton, he is with Cal-State at Fullerton, also part of the Earth Forensics group as well. We are at the Irrigation Association and also the National Groundwater Association Convention in Las Vegas. I'm Brian Winnekins for Real Country 1430 WRDN.